Okay, in this problem we have a veterinary clinic that wants to be able to determine what the human year equivalent is of the cats and dogs that are brought into the clinic. So this is the paragraph that they did, and this is a little example. So if the person comes in with a cat that lives inside all the time and is 10 years old, that multiplier is 7. So that means that it's 7 times 10, and it's actually a 70-year-old in human equivalent years. All right, so let's take a look at what we need to do. First is, what do they want out? And they want the human years. All right, so that's the human equivalent of whatever the animal's years are. And how we're going to get that? Well, we have to calculate it, so we'll go ahead and copy this, paste it up here, and say this is equal to whatever the animal's age is. So we'll call that animal animal years. I'm going to just call that age. Yeah, good idea. We'll call this age. Age times whatever the rate is. So the rate's going to be one of these multipliers up here. All right, so the next thing we need to do is figure out, well, we have to get the rate and we have to get the age. So the age is pretty easy because someone's got to tell us that. So we'll go ahead and copy this and paste it up in the input. All right, the rate is going to be one of all these rates here. So those are going to be constants because they're not going to change every time we run the program. So let's come up here and see that we have, so inside cat is 7. So we'll say inside cat rate equals 7. And then we'll have outside cat rate. And you can see I'm cameling these to make it easier on us a little bit later on. Cats to the outside are 8. And then inside dog rate is equal to 6. And then we have an inside dog rate, and that's going to be equal to 7. Now you might be tempted to use this 7 twice because inside cat and inside dog are the same. Say, well, if it's inside, it's 7. But then what happens if we recalculate this later on and they say, well, inside cat stays at 7, but now an inside dog rate is 8. Well, then that would match that. So it wouldn't make a difference. We'd be chasing our tail trying to figure out how to combine these. But these are actual separate rates. They just happen to be the same in this instance. All right, so now we have all the rates, but the rates are dependent on the type of animal that we're looking at or trying to calculate. All right, so let's go ahead and move this up a little bit. We're going to say that if the pet type is a dog, then the rate is going to be equal to, so if it's a dog, then what is the rate? Well, there's 2 rates for dogs, so that we can't put that in there. We have to say, well, if it's a dog, then we have to find out whether it's inside. Whoops, made a mistake there. And that's why going back through this one, say dogs that say inside all the time is 6, so this should have been outside dog. Outside. All right, so as we can keep checking as we go through and find these errors. All right, so we have to make another decision here. We can't determine the rate, so we have to say that if the living location is equal to inside, then now we can go ahead and figure out the rate. And the rate for a dog living inside is going to be the inside dog rate. So let's go ahead and copy this and paste it in. All right, so we don't do cat now because we're still working on dogs. Right now we have, well, if it's inside. So now we have to see if it's outside. Now we don't test to see if it's outside because it's either inside or outside. We just say else, which means if it's not inside, it's automatically outside. And then that means the rate is going to be equal to outside dog rate. And you see I'm typing rate. I should be copying and pasting, but I think I can type 4 characters without making an error. But the more you copy and paste, the less errors you're going to make. But okay, so now we have both dog locations covered. So the next thing I have to figure out is, well, what happens if it's a cat? Well, we don't say if pet type equals cat. We just say else, because if it's not a dog, it's a cat. There's only 2 types of animals. That's called a Boolean. And when we have a Boolean values, then we use the else. If it's not one thing, then else it's another. These are going to be the same, pretty much. So I'm going to go ahead and copy this and paste this down here. So the only difference between the top and the bottom is that down here we're using cat rate rather than dog rate. So I'm going to come up here and copy cat because that's what we're using, and come down here, and every place I see a dog in the bottom part, I'm going to change it with cat. If we are consistent with our naming, it makes our coding a lot faster, because if we call these 2 completely the inside cat rate and then dog inside rate, then we'd have 2 different types of naming conventions, and it would be a little more confusing and a little bit more difficult to copy and paste. So that looks like we have everything. So these are the 4 different ways that animals can be, either inside dog, outside dog, inside dog, cat. The only thing we don't know is living location. We haven't determined that, and someone has to tell us what that is. So that's an input. So I'm going to copy that and place it here. We also don't have dog type covered, and that someone has to tell us too. So we copy that and we paste that in. So now that we have covered everything that we have, I declare this over. So let's go ahead and make a human algorithm real quick. I'll come down here, human algorithm, and then I will simply put a bunch of spaces in. Okay, and then paste. Really, on this one, it's pretty easy because all I have to do is get rid of all the spaces. Again, we might be wondering, well, why didn't we just leave the spaces out in our problem statement? That's because the problem statement is for a human. This human algorithm, although it's for a human, also no one sees it but us. So we can go ahead and camel it, but it will look kind of strange if we're talking to the vet and telling him what we're going to do. And he says, well, wait a minute. I don't know why are there are no spaces and anything here. And then we'd have to go and explain what cameling is and all that. So we have, that's why we have 2 different things. Plus we learned in the last one that we had that the human algorithm sometimes is not in the same order as input calculations and output. And the more complex the problem, the more that happens. So we needed really 2 tools in order to be able to do that. All right, I have taken out all the spaces. And the only thing I have to do is determine what scope is there. So we can say only 2 types of animals. And when I ask my vet that, he says, well, sometimes we also treat gerbils, and gerbils are something else. And then we say, okay, we'll have to change my solution then. Only 2 types of living locations. And then I said, well, there's only can be is inside and outside. And he goes, well, sometimes they're indoor, outdoor, which means they spend most of their time indoors, but they spend some time outdoors, and that's going to be a different multiplier. Well, then it changes my whole solution. So it's a good thing I would have asked that question. And the last one is only one animal at a time. So only one animal at a time will use this process. It says, well, sometimes people bring in 3 animals, and I hate to have to run it 3 times, so can you make it so that we can do more than one animal at a time? I said, well, I can do it, but it's going to not be this solution, it'll be something else. And again, that's why we put these scope problems in. All right, that's it. Next, we're on to flow charting.